So this is the Waves Homework Booklet, questions 5, 6, 7, 8, 9. First question, typical question, the least distance between 2 points of a progressive transverse wave with a phase difference of pi by 3 radians is 0.050 meters. The frequency is 500 Hz. What's the speed of the wave? I'm straight away thinking C equals F lambda. I've got the frequency. What I haven't quite got is the wavelength, so I've got to work out what the wavelength is. But I've been told that I've got 2 points that are pi by 3 apart, and that's a distance of 0.50. Now, phase difference is 2 pi times x upon L is one way you can do it and get to the fact that the wavelength is 0.3 of a meter. Or you can simply think pi by 3, well, a whole cycle is 2 pi radians, so pi by 3 is a sixth of a cycle. So if I multiply the distance we've been given, the 0.050 meters, by 6, I get 0.3 meters, which is the wavelength. So 2 pi radians for the whole cycle, pi by 3 is a sixth of that, so the distance we've been given must be a sixth of a wavelength, so wavelength is 6 times that 0.050, 0.3 meters. Then it's a straightforward C equals F lambda with 500 and 0.3, leaving me at 150 meters per second, so the answer is C. Question 6. How many times is the wavelength of audible sound greater than the wavelength of light waves? Well, you've got to use 2 bits of knowledge. Light waves is somewhere around 10 to the minus 6, 10 to the minus 7. It's a few hundred nanometers, so it's between about 4 times 10 to the minus 7 and 7 times 10 to the minus 7. Well, 7 times 10 to the minus 7 is around 10 to the minus 6. Sound. How about a wavelength of sound? Well, one thing you know is that sound diffracts very well through a door. Doors are about a meter, so the wavelength of the sound wave must be about a meter. So if I divide that 1 meter by the 10 to the minus 6-ish meters, I end up with the multiplier after, which is 10 to the 6. So the answer is that it's B. Question 7 is another phase and C equals F lambda question. So we've got a speed this time, we've got C, and we've got a frequency. We're after a minimum distance between 2 points which are pi by 3 radians out of phase. So, again, I'm going to use C equals F lambda. Rearrange that. Lambda is C over F. 1500 is the speed we were given. F is 250 Hz we were given. That gives me a wavelength of 0.6 meters. We're asked for the minimum distance between 2 points which are pi by 3 out of phase. Again, pi by 3 is a sixth of a cycle. A whole cycle is 2 pi radians, so pi by 3 is a sixth of 2 pi, so we've got a sixth of a cycle, and therefore the distance between those 2 points is going to be a sixth of that wavelength, 0.1 meters B. Again, if you're happier using a formula rather than thinking it through, we've got the phase difference is 2 pi x over lambda, and from that I can work out my x, 0.6 over 2 times 3 from rearranging it, and I get to 0.1 of a meter. Moving on to question 8, which cannot be polarized? As soon as I see which cannot be polarized, I'm thinking transverse longitudinal. If I want one that can't be polarized, then I've got to look for a transverse wave. There's only the other 3 are electromagnetic waves. All electromagnetic waves are transverse. All transverse waves can be polarized, so it can't be A, B, C, D. Ultrasound, I know, is a sound wave. It's just a very high frequency sound waves. It's longitudinal. It cannot be polarized. The answer is D. And then it's a slightly more complex version of the thing we've had a couple of times already. We've got 5 Hz at 8 kilometers per second. What's the phase difference in radians between 2 points that are 2 kilometers apart? I've just realized that I need to pause this. And you may have noticed I've very subtly added in a little k, because lambda is the wave speed divided by the frequency. It's 1.6 kilometers. The 8 kilometers per second divided by 5 Hz gives me 1.6 kilometers. Now the phase difference for those 2 points 2 kilometers apart, I could use phase difference as 2 pi times x upon lambda. So x is 2 kilometers, lambda is 1.6 kilometers. Strictly, I suppose those should both be in kilometers, but they just both have a times 10 to the plus 3 after them, which would cancel straight off. That gives me 2.5 lambda. Now the only thing is that, sorry, 2.5 pi radians, and the only thing is, and I'm going to pause again, 2.5 pi radians is exactly the same as half a radian. If things are 2 pi radians apart, they're in phase. So a phase difference of 2.5 pi radians is the same as the phase difference of half a pi radian, pi by 2 radians. So the answer's B. Remember, from a phase difference you can add or subtract as many multiples of 2 pi radians as you want. So that's the wave booklet, questions 5, 6, 7, 8 and 9.